All right, in this video, they're asking us to simplify this radical. So the first thing we want to do is to try to factor what's underneath the radical. So the way we're going to do this, we're simply going to say, okay, we're looking at the third root of. The factors of 8 are basically 2 times 2 times 2. And then x cubed, of course, is x times x times x. And then y to the 12th, well, you can tell that writing that out is going to be pretty difficult. What we're doing is actually trying to look for groups of 3 of them in a row. I know that I could do, for example, y to the 4th, y to the 4th, y to the 4th. I could do that if I want to split it up into 3 equal chunks, right? Because y to the 4th times y to the 4th times y to the 4th would give you y to the 12th. Now we're using this approach because we want to use that general idea that if the index is 3, that means for every 3 things that are the same underneath the radical, I can pull them out as 1 outside. That means this 2 will come outside as a 2 out in front. The 3 x's, I can take one of them outside, right? So an x outside, so it'll be 2x. And then because there are 3 y to the 4th, I can take one of them outside to give me y to the 4th. And now there's nothing left inside, so I can just say that my final answer is 2x y to the 4th. And that's the solution for the first one. That's as simplified as you can write that. All right, let's get another example. Example B. Okay, so to tackle B, we want to try to factor it. Remember, when in doubt, factor it out, right? So in other words, factor what's inside of this radical in order to be able to see what you can pull out. All right, let's factor 162 first off to the side here. So I know that 162 has a 2 in it for sure because it's even. So if I do 2 divided into 162, I will get 81, right? Because 2 goes into 16 8 times, and then 2 goes into itself once, so 81. Now the 2 is prime, so I'll circle that. Now how about the 81? Well, 81, remember, is 9 times 9, or 9 squared, and that can be broken up further as 3 times 3, and 3 times 3. All right, the reason why that's helpful is because you can now see we have 4 3's, and the index on our radical is indeed 4. So we're going to need things to be repeated 4 times to be able to take out one of them. Okay, so now what we're going to do is to write the 162 as 2 times 3 times 3 times 3 times 3. And then we'll have x to the 7th as x times x times x times x times x times x times x. Now again, you don't have to write it all out. We could summarize that. We're going to show how to do that after we finish this one. But let's just say that the 4 3's here will allow us to take 1 outside, right? So we'll have a 3 outside. Then for 4 of these x's, I can take out 1 outside. So I'll have an x outside. But then you can see we're left with a 2 and 3 x's inside. So underneath this radical, we're going to have 2 x to the 3rd power. That can't be simplified any further. So that's our answer. So in order to do example C, it's a fraction, and you can actually, if you want to, you can actually simplify under the fraction first and then apply the radical, or you can apply the radical to the numerator separately and the denominator separately. Either way is fine. This time I'm just going to work it as the numerator as a separate sort of problem and the denominator as a separate problem. This way I can demonstrate how that's done, but of course we could have also simplified first and then applied the radical. But you're allowed to put the radical in the numerator and the denominator separately like I've just done here. So let's go ahead and do that. All right, from here you can begin to simplify. Let's go ahead and factor again like we've been doing. Remember, we're looking for pairs. So for example, 4 is 2 times 2. Because the index here on this radical is 2, we can actually take out anything that has a matching pair. So 2 times 2, which makes 4, we can take a 2 out for that, right? Now x to the 4th can be written as x squared times x squared, right? For every pair, we can take out 1. And then y squared can be written as y times y. Okay, and in the denominator, we can take the 25 and write it as 5 times 5. And then for the y to the 6th, you might want to write that as y to the 3rd times y to the 3rd. And then for the z to the 8th, you can do z to the 4th times z to the 4th. So that factoring is correct. Now, remember our strategy. For everything that has a matching pair, we can take one outside when it's a square root. So for these 2's, I can put a 2 outside in the numerator. For these x squareds, I can put an x squared outside in the numerator. For these y's, I can take a y outside in the numerator. In the denominator, I can take a 5 outside. I can take a y cubed outside. And finally, I can take a z to the 4th outside. Now, we would be done at this point, except for we need to simplify if we can. So for example, we'd have 2x squared times y over 5y to the 3rd z to the 4th. We have common terms here with the y's in the numerator and the denominator, so we can combine those to simplify. So remember how this works. It's basically like doing this. I'm just writing this out so you can see this if you don't remember your exponent rules, but the y cubed is really y times y, correct? Then we have z to the 4th. Well, of course, this y up top can cancel with one of the y's at the bottom, and what you'd be left with is 2x squared over 5y squared z to the 4th. And that is your answer.